My class is completed. Sorry for the disturbance. Yeah, fine. So now we have to explain about the biot savart, right?
Yes.
Yeah, biot savart. So keep deciding biot savart. For example, if I take it as a current carrying conductor which is carrying the current I, I'll take small portion of the conductor which is taken as dA, and I will take it as a point P, which is at a distance smaller, and I will take this angle as theta. Then, according to the biot savart law, the magnetic field dV at this point, the magnetic field dV at this point is directly proportional to the current passing through the conductor. Okay, so please remember, if I take a magnetic field dV at this point, no, it is directly proportional to, I into dl. I'll take it as equation number 1. So where I into dl is nothing but current element. So magnetic field at a point, is directly proportional to, it is directly proportional to current element. And similarly, it is inversely proportional to, second point, magnetic field dV is inversely proportional to, it is inversely proportional to square of distance. It is inversely proportional to square of distance. That is dV is inversely proportional to r square. Take it as equation number 2. And this magnetic field dV is directly proportional to, magnetic field dV is directly proportional to sine of angle between them. Sine of angle between them. Sine of angle between dl bar and r bar. That is dV is proportional to sine theta. Take it as equation number 3. From equation number 1, 2, 3, dV is proportional to I dl sine theta divided by r square. Then if you remove the proportionality, you can write down the constant. That constant value is mu naught by 4 pi into I dl sine theta by r square, where mu naught by 4 pi is the constant value. Now, where mu naught by 4 pi is the constant value, that is equal to 10 to the power of minus 7. And the units, I'll tell you the units directly. Tesla, meter, ampere inverse. Okay, just remember this. Again, we'll discuss how this units came. So please note it down. This is the formula for biot savart. Is it done?
Yes, sir.
The next point, this biot savart law we can express in the vector form also. Biot savart law we can express in vector form also. So how to explain this biot savart in vector form is dV bar is equal to mu naught by 4 pi into, you can write it as I dl bar cross r bar divided by r cube. Shall I write like this? Because I dl bar cross r bar value is I dl into r into sine theta divided by r cube, means r cube and r square will get cancelled, then I dl sine theta divided by r square. Understood this point? So this is the vector form of biot savart law. Okay, here mu naught is called as the permeability. What do you mean by permeability? Means the property of allowing the magnetic lines of force, that is called as permeability. No, what do you mean by permeability? Means the property of following the magnetic lines of force. That is called as permeability. Okay. So please note it down. If you didn't copy also, I keep it like this. You just copy. Yeah. Shall I explain the next part?
Yes.
So write down few note points, which is very important for competitive. Just give me 1 second. Could you see the screen now?
Yes, sir.
Okay, fine. So I'm giving you one note point. One minute. No? Write down note point. Could you see the screen? Screen is visible.
Yes, sir.
Yeah. Now listen. Note. The first note point is, for example, if you take magnetic field, B is inversely proportional to R square. For example, if R is equal to infinity, then what is B value is, then B value is 0. So magnetic field will be 0 at infinite distance. Therefore, you can take a magnetic field as a long range force. Now you can take magnetic field as what? A long range force. And second important point, if you take electric field value K Q by R square. So electric field is due to, no, electric field is due to, electric field is a vector. No, electric field is a vector. It is due to scalar quantity. No, it is due to scalar quantity. Which is the scalar quantity? Means charge. Charge is a scalar quantity. But if you take magnetic field, so magnetic field formula mu naught ideal, mu naught by 4 pi into ideal, where ideal bar is called as what? Ideal bar is called as current element. Current element is a vector quantity. Okay, so please remember, where if you take b bar, so b bar is a vector, magnetic field is a vector, it is due to, okay, vector quantity. It is due to vector quantity. So what is that vector quantity? Means ideal bar, so which is called as current element. Okay, so current element, these two are the theory based questions. Now most important thing, for example, if point p, no, for example, if point p is taken along, if point p is taken along the length of the conductor. Now this is very important. Based on this point, we have number of problems for JEE and NEET examination. Okay, base, if point p is taken along length of the conductor. For example, if this is the wire and this is the small elemental dl, current passing through the conductor is I. Now this is the point p, which is making an angle theta. If I take the point p along the length of the conductor, can you tell me what is the theta value? Can you tell me what is theta value? Now if I take this point p along the length, so I will bring this point p here. Then what is the theta value? Hello. Huh, what happened to you? So much dull. See, this is the conductor. This is the DL. This is the point P. This is the angle theta. If I take the point P here, what is the theta value? Man?
0 degree.
For that, this much time, 0 degrees. Or not interested. Because something has to reply it. So if theta is equal to 0, then we can write dB bar or dB is equal to, okay, mu naught by 4 pi I dl sine 0. What is sine 0 value?
0.
0.
What is a magnetic field? 0. So if point P is taken along the length of the conductor, then magnetic field is 0. This is a very important point. Okay. So if you're done with this, I'll go for the next concept. Shall I move?
Yes, sir.
Now keep the citing applications. In that, the first application, magnetic field due to straight current carrying conductor. Now for this, derivation is not required. In our NCRT also it is not there. And here also I'm not going to explain the derivation. Directly I will use the equation. Okay. Magnetic field due to straight current carrying conductor. Please remember, if I take it as a current carrying conductor, which is carrying the current I, now I will take it as a point P, which is at a distance R from the conductor. Now this is the first end of the conductor, I'll take it as A. This is the second end of the conductor, I'll take it as B. Now first end of the conductor is making an angle alpha with the point P. Second end of the conductor is making an angle beta with the point P. Then what is the formula for magnetic field due to the conductor? Means B is equal to mu naught I by 4 pi R into sine alpha plus sine beta. This is the formula. Okay, so this is the expression for magnetic field to current carrying conductor. Okay, so mu naught I by 4 pi r into sine alpha plus sine beta. Okay, students. Now please remember, in this I am going to explain subcases. For infinite long straight conductor. Now for infinite long straight conductor, please remember. My infinite conductor means we have to increase the side of this and this. Then if I take it as point P, with this side it is making an angle alpha. So if I go up to infinity, then this angle alpha value increases or decreases. If I go up to infinity, now if I go up to infinity, this alpha value increases or decreases. Now if I take it as a point P, this angle is taken as alpha. Now if I go up, keep on going up, if I keep on going up, then alpha value increases or decreases?
Increase.
Increases.
Decreases, right? So for
Yes.
infinite wire, alpha value is approximately equal to 90 degrees. And similarly, other side also increases, beta value also increases, And if you go up to infinity, beta value also approximately equal to 90 degrees. Now substitute alpha 90, beta 90, then magnetic field B is equal to mu naught I by 4 pi r into sine 90 plus sine 90. Sine 90 is 1, sine 90 is 1, 1 plus 1 that is 2. Cancel to 1 z 2 2 z. Then magnetic field B is equal to mu naught I by 2 pi r. Did we learn this expression anywhere else? Mu naught I by 2 pi r.
Yes, sir.
Yeah, we studied, right? What is the value? For whom it is?
Magnetic field due to
Yeah, magnetic field due to infinite long straight current carrying conductor. Yeah, if you're done with this, I'll go for one more thing. Shall I move on? Next point. Yeah. So, for example, if I take semi-finite wave, this case is very important. So mostly problems will come from these cases. Okay. For semi-finite wave, for semi-finite wave means the point P has to be at one end. Please remember, semi-finite wave point P has to be at one end, and the other end will be at infinity. My point P is at one end. This distance is nothing but r. Now, can you tell me what is the alpha value?
0 degree.
Point P is taken at one end, my here. Then tell me what is alpha value? 0. Then beta value is 90 degrees because this side it is keep on increasing. Now this side it is keep on increasing. Then beta value is 90. Then substitute alpha 90, beta 0. Sorry, alpha 0, beta 90. Then what is the magnetic field means? B equal to mu naught I by 4 pi r into sine 0 plus sine 90. Sine 0 is 0, sine 90 is 1. Then magnetic field B is equal to mu naught I by 4 pi r. This is the magnetic field to semi-finite wire. Yeah, please note down this point. Is it done?
Yes, sir.
Based on this, I'm going to give you some problems. Okay. Now the problem is, now problem number one. In the last class, okay, fine, fine. So next one more concept I'll tell you. Based on that, we'll discuss the problems. Okay. So write down a second application. Write down a second application. And one more thing. What is the direction of this current carrying conductor? Means the direction of this current carrying conductor. Direction of the current carrying conductor can be measured from the second application. Yeah. So actually previously the direction of magnetic field of the straight current carrying conductor. Please remember, for straight current carrying conductor, we have to apply right hand thumb rule. Now, for straight current carrying conductor, we have to apply right hand thumb rule. So please remember this. Okay, for straight current carrying conductor, we have to apply right hand thumb rule. Now, I'm going for the next concept, that is magnetic field due to circular current carrying conductor along the axial line. Okay, ma? So please keep this idea. And this is very important 5 mark question for your PU examination point of view. Damn sure question. Okay, shall I explain this question? Now listen. For example, I'll take it as a current carrying conductor. For example, capital R be the radius of the conductor or radius of the loop, circular loop. This is circular current carrying loop. Therefore, capital R is the radius of the loop. Let us suppose I is the current in the conductor. Now, for example, X is distance from center of the coil, to the point B. Okay. Now, please remember, this concept is bit difficult, not difficult, like different to understand. That I will explain now. Just to see. Let us suppose this is the current carrying conductor. Now, let us suppose this is the current carrying conductor or current carrying loop, and this is the axial line, and this is the radius. Now, I will imagine a small length on this conductor. I will take the small length as dl. Do you understand this point?
Yes, sir.
Now listen. This is DL, and I will take the distance from here to here as, for example, smaller. So this is DL, this is smaller. Then you can imagine one plane for DL and smaller. Now this is the plane for DL and smaller. Did you understand this point or not? Okay. Now listen. For example, if you apply the Biot-Savart's law in vector form is dv bar is equal to mu naught by 4 pi into I dl bar cross r bar divided by r cube. Now from this we can say dv bar is proportional to I dl bar cross r bar. It looks like which product now?
Cross product.
Yeah, vector product, a scalar product, or cross product. I mean, which product is cross product, right?
Vector product.
The vector product. Then tell me db bar. Okay, what about the db bar direction? What about the db bar direction? Can you tell me what is the db bar direction? What is the direction of db bar? Yeah, was no vector product now. So many times we discussed that. In vector, resultant will be what always. Anyone is there now?
DB bar is perpendicular to DL bar and R bar.
Very good. So dv bar is perpendicular to dl bar and r bar. Thus, this is dv bar. Because dv bar will be perpendicular to dl bar and r bar, plane of dl bar and r bar. So this is a vector only, right? So you can imagine this dv bar anywhere. This imagine dv bar at anywhere. I imagine this dv bar at anywhere. So I will imagine this dv bar here. Did you understand this point or not? Because in the entire concept, this is the major thing. If you
Yes,
understand
sir.
this, you can so answer the concept very easily. Remember, dB bar perpendicular to DL bar cross R bar means dB bar is perpendicular to DL bar and dB bar perpendicular to what na R bar. Am I right or not?
Yes, sir.
Yeah. Because dB bar will be perpendicular to the plane of DL and R bar. This is the plane of DL and R bar. Okay, so this is the concept. Actually, this important point or major point it is missing in NCRT. Not only NCRT, in every textbook they missed or they skipped this point. But this will plays the major role in the entire derivation. I hope you understood this point. Now I'll go for the derivation. Now listen, I will take this as small elemental length and I'll take it as small elemental length dl. Okay, now I will take this distance as, for example, r smaller. I'll take this distance as smaller. Then dv bar will be perpendicular to the plane of b bar and r bar, dl bar and r bar. Now the same vector I will shift to here. Now I'll take this as, for example, db bar. Do you understand this point or not?
Yes, sir.
Now according to the Biot-Savart's law, if I take this as small elemental length dl, if I take it as point B, the angle between R and DL is taken as theta. Now this is R, small r, and this is DL. So this angle is taken as what, no, theta. Do you understand this point or not?
Yes, sir.
If this angle is theta, this angle is 90, then tell me what is this angle? No, this angle is theta, this angle is 90 because it is perpendicular. What is this angle?
90 minus theta.
Very good, 90 minus theta. Now, this dv bar, I will resolve into two components. For example, I'll take it as one component. I'll take it as another component, two perpendicular components. Now, can you tell me what is this total angle? 90. In this total angle, this angle is 90 minus theta. Can you tell me what about this angle? Now, this is 90 minus theta. Can you tell me what is this angle? Hello?
Theta.
Very good, theta. Now, please try to understand. This is R bar, this line is R bar, this line is R bar, this is dB. R bar and dB bar are perpendicular to each other, right? So R bar and dB bar are perpendicular to each other. So just now here only I wrote it. So R bar and dB bar are perpendicular to each other. Then can you tell me what is this angle? 90 minus theta. Because these two are perpendicular, right? So therefore, if this angle is theta, then this angle will be 90 minus theta. If this angle is 90 minus theta, again, this component and this component are perpendicular to each other. Therefore, again, this angle becomes theta. Okay, so this is the concept. This is what I'm going to explain. Okay, so if this angle is theta, then this angle will be 90 minus theta, then this angle will be theta. Again, R bar and dV bar are perpendicular. Therefore, this angle will be 90 minus theta, then this angle will be theta. So this is how we got the theta value. Do you have any confusion or completely confusion?
No.
No, sir.
Now, if this is theta and if this is dB, now can you tell me what is this component of magnetic field?
dB sin.
Cos theta. And what is this component of magnetic field? This is dB sin theta. Now, please remember, along the horizontal, we have the magnetic field dB cos theta. Along the vertical, we have the magnetic field dB sin theta. Now, we have to calculate the magnetic field along which line? Axial line, right? So along the axial line, magnetic field is taken as dBx, which is equal to B cos theta. Along the y component, magnetic field is taken as dBy, which can be taken as dB sin theta. Okay, now please remember. I'm going to explain from Biot-Savart's law. So from Biot-Savart's law, now from Biot-Savart's law. Okay, so I'll take Biot-Savart's law in vector form. What is that? Means dB bar is equal to mu naught into I dl bar cross r bar divided by r cube. Now let us suppose theta value is equal to 90 because dB bar is perpendicular to the plane of dl bar and r bar. So if I take theta value as 90, then dB is equal to mu naught I dl sin 90 is 1 into r divided by r cube. Cancel r and r. So that implies magnetic field dB is equal to mu naught I dl by r square. Did you understand this step or not?
Yes, sir.
Okay, so here I will consider theta value as 90 because dB bar is perpendicular to the plane of dl bar and r bar. Now, I will consider like this. Now, for example, here dB bar at point P, now dB bar at point P is resolved into two components. Yeah, can you tell me what are the two components? dB cos theta along horizontal. Now, dB cos theta along horizontal. And dB sin theta along vertical or along y-axis. Then dB cos theta along x-axis horizontal, dB sin theta along y-axis that is vertical. Okay. Now please remember, if I take this DL bar at the bottom, again you will get a DB bar in this direction. Then this will be DB sin theta, this will be DB cos theta. Now please remember DB sin theta components. If you take due to upper wire, DB cos theta sin theta will be in this direction. If you take the lower one, DB sin theta is in downward direction. Now these two are equal and opposite directions. Now therefore, the vertical component of magnetic field will be zero. Are you clear? So I'm including that point. For example, if we consider DL bar at the lower portion. Now, if you take DB bar at lower portion, then what will happen means, okay, DB sin theta components will get cancelled each other. Now, DB sin theta components will get cancel each other. Okay, so please remember this. Now, DB sin theta components will get cancelled each other. Then we have, okay, then we have magnetic field. Then we have magnetic field along which direction dV cos theta. Do you understand this point, students? This is the most important point in this entire derivation. So dV is resolved into two components, dV cos theta and dV sin theta. But dV sin theta components will get cancelled because current will passes through in the entire conductor, right? For example, current is passing like this means current is will flow in the entire conductor, right? If current is flowing in the entire conductor, current flows to the lower portion, current flows to the upper portion. Due to upper portion, magnetic field is in upward direction. Due to lower portion, magnetic field is in downward direction. Therefore, upward direction, downward direction, magnetic field will cancel each other. Then we'll get magnetic field only along the x-axis. Then we'll get magnetic field only along x-axis. Therefore, if I take along magnetic field x-axis dbx, that can be taken as db cos theta. Okay, so only magnetic field will be present along which component? dv cos theta. The dv cos theta here we consider as dbx. Now from equation number one, we can write, dB value is mu naught I dl by r square into cos theta. Did you understand this point? Okay, from equation number one. So in equation number one value, I am substituting here d in the place of d. Okay, students. Now see, I will explain few things. Look at the figure, no, from figure. I'll take the figure. So this is the figure. This side is x-axis. Now this side is x-axis, and this is y-axis. Now along the x-axis, what is the distance means x? Along the y-axis, what is the distance means r? Now it looks like a right angle triangle. Can you tell me then what is small r equal to?
R square plus x square.
Very
R
good.
square plus X square.
Very good. Square root of capital R square plus x square. Okay. Or you can write like this also. Small r square is equal to capital R square plus x square. Now tell me, from the figure, look at this figure. This is taken as O. I'll take this point as P. I'll take this point as Q. From the triangle OPQ, what is the cos theta value from the triangle OPQ? Look at the triangle OPQ. From the triangle OPQ, what is the cos theta value?
X by square root of r square plus x square.
Very good. Very good. So cos theta value, cos is nothing but adjacent side. Cos theta is adjacent side. Adjacent side is OQ divided by hypotenuse. Hypotenuse is PQ. So from the figure, if I take cos theta value, if I take triangle POQ, okay, cos theta value. What is cos theta value? Is OQ of adjacent side by QP. Clear? OQ by OQ is the adjacent side. PQ is the hypotenuse. Now I will write like this one. OQ value is capital R. So OQ value is capital R. So if I take OQ value, OQ value is capital R. And PQ value is smaller. So capital R is smaller. Now if I substitute this value in this equation, I'll take it as equation number 2. So from equation number 2, you can write like this one. dBx is equal to mu naught IDL by R square into cos theta values capital R by small r. That can be taken as mu naught IDL R by R cube. Okay, students. Then you can write dBx equal to mu naught I R by R can be taken as what is R value? R square plus X square under root. That under root can also be taken as that under root can also be taken as R square plus X square whole to the power of 1 by 2. If in the place of smaller value substitute R square X plus X square whole to the power of 1 by 2 and this is cube. Therefore, you will get it as 3 by 2 into dl. Understood this point now? Therefore, to get the total magnetic field, but to get total magnetic field, integrate on both sides. If you integrate on both sides, integration of dBx is equal to integration of mu naught IR by R square plus X square whole to the power of 3 by 2 into dl. Then I'll write like this now. Integration of dB, my integration of dBx is taken as bx because integration of bx dx value is x. My integration of bx value, we have the formula that is equal to x. The integration of d into bx, that value is bx. You can write it as mu naught I by r into, okay, r square plus x square whole to the power of 3 by 2. Sorry, mu naught I by 4 pi r, I missed 4 pi. No, sorry, I missed 4 pi. Because Biot's of formula only mu naught I by 4 pi r. Sorry, I forgot no 4 pi. Sorry. So this is the value. So mu naught I by 4 pi r. Okay, if you take integration of dbx, that is bx, you can take mu naught I r by r square plus x square whole to the power of 3 by 2. I'll take 4 pi also out of the integration. That is integration of dl. But tell me, integration of dbx gives bx, then integration of dl will gives what?
L.
L, where L is total length. Now, if you observe the figure, dl is the small length. Now, dl is the small length. Okay, if you observe the figure, dl is the small length. So, if you integrate dl, you will get the total length. Now, you will get the total length. What is the total length? Can you tell me? If you integrate the dl, you will get the total length. Can you tell me what is the total length? Yeah, tell me now, please. Circumference, right? That is nothing but 2 pi r. Now, if I take it as a circle, the small length is dl. If I take total length, that will give circumference of the circle. That circumference of the circle is 2 pi r. That circumference of the circle is 2 pi r. So integration of dl is nothing but L. Now integration of dl is nothing but L. That L is taken as, now that L is taken as 2 pi r. Now that L is taken as what? 2 pi r. Now cancel 2 pi 4 in 2 times. Then finally you will get a magnetic field Bx as mu naught I r square by, this is 2 into r square plus x square whole to the power of 3 by 2. This is the magnetic field due to circular current carrying coil. Okay. Now based on this, we have some shortcut formulas as well as some problems are there. I will explain. Will you copy from first onwards? Will you please copy this? For your PU examination, it is very important for 5 marks question. Did you copy it up to here?
Yes.
Then copy this rest of the derivation. Yeah, did you copy it? Is it done now? Copied? Huh?
Yes.
Yes, sir.
Now listen. Now based on this, we'll discuss most important things. Write down first note point. For example, if coil contains n turns, if coil contains n turns, then magnetic field is taken as Bx equal to mu naught Ni r square by 2 into r square plus x square whole to the power of 3 by 2. This is the magnetic field because of n turns. Now please remember, for example, if point, okay, is kept at the center. If point is taken at the center, for example, I'll take this point as P. If this point is taken at the center, then what is the x value means then x equal to 0. If I substitute x equal to 0, then magnetic field is given by the formula mu naught Ni r square by 2 into r square plus 0 square whole to the power of 3 by 2 because x equal to 0. Then that can be taken as mu naught Ni r square by this value is 2 into r square whole to the power of 3 by 2, that is r cube. Then r square will cancel r cube by one time. Then magnetic field B is equal to mu naught Ni by 2r. This is the magnetic field due to the circular current carrying coil at the center. Okay. And next point, no? For example, if you take magnetic field due to the arc, this is the arc which is carrying the current I, no, which is carrying the current I. So this is the arc. This is the magnetic field due to the current carrying arc. Now it is making an angle theta with the center. Now it is making an angle theta with the center, and which is having the radius r. Then magnetic field due to the arc. Magnetic field actually n value is equal to 1, no? Mu naught I by 2r into theta by 2 pi. Please remember this point. Now magnetic field due to the arc at the center. This is the formula. Please note it down. Based on this, we have number of problems. So many problems out there. For example, if the arc is a semicircle, if this arc is a semicircle, what is the theta value? If arc is a semicircle, what is the theta value?
180 degree.
180 degrees. Okay. For example, if arc is like this, if arc is like this, now what is theta value?
90 degree.
90 degrees. Okay. Shall I move?
Yes, sir.
Now the next concept is, for example, if I take point at very large, if I take point at very large, if x is much greater than r, that implies r is much less than x, then r square is very much less than x square, then r square by x square is approximately taken as 0. Okay. Now take this equation b is equal to mu naught ni r square by 2 into r square plus x square whole to the power of 3 by 2. Now please remember, from this equation, I will take x square as common. If I take x square as common, then what is this value means? So 2 into, if I take x square as common, first term is r square by x square plus 1 whole to the power of 3 by 2. But tell me what is the value of r square by x square? Now tell me what is the value of r square by x square? 0,
0.
right? Then magnetic field B is equal to mu naught ni r square by 2 into x square whole to the power of 3 by 2. Cancel these two. Then what is the formula for magnetic field means? Mu naught ni r square by 2x cube. This is the answer. So please note it down. Yeah. Is it done now?
Yes, sir.
Yeah. So from this equation, I will tell you one small conclusion and we'll wind off today. So what is that conclusion means? Here, E is equal to mu naught ni r square by 2x cube multiply and divide with pi r square. Sorry, multiply and divide with pi. If you multiply and divide with pi, then you can write like this: mu naught ni pi r square divided by 2 pi into x cube. Understood this point? And multiply with 2 on both sides. Multiply and divide with 2, or else directly divide with 2 pi, then it will be better. Then this is 2 mu naught I by, this is 4 pi x cube. Should I write like this? Now listen. Pi r square is nothing but area. So area A is equal to pi r square. Then in the next step, I'm going to write like this one. Then B is equal to mu naught by 4 pi. I will write it as common. You can write it as 2 into n into I into A divided by x cube. Now 2 into NIA divided by x cube. Now please remember n into I into A. This is taken as m, where m is called as magnetic dipole moment. No, when m is called as what? Magnetic dipole moment. Actually, this concept we will study in the next chapter, but in this chapter we have problems based on this. Okay, capital M is called as what? Magnetic dipole moment. Please remember, magnetic dipole moment is represented with m. That m formula is NIA. This m is a vector quantity. Now this m is a vector quantity. The direction of this m bar is from south pole to north pole. Please remember this. Now, can you tell me what is electric dipole moment? You tell me what is electric dipole moment? E bar is equal to 2L into Q. Do you remember? This is the electric dipole moment. Now, electric dipole moment direction is from where to where? Very good. Negative to positive. Electric field direction. Electric field direction positive to negative. So electric field direction positive to negative. Electric dipole moment direction negative to positive. In the same way, magnetic field direction north to south. The magnetic field direction north to south. Magnetic dipole moment direction south to north. That is the important concept. Then you can write magnetic field B is equal to mu naught I by 4 pi into 2 into capital M by x cube. Okay, this is similar to, no, this is similar to electric field formula 1 by 4 pi epsilon naught 2 p by x cube. What is the formula for this? Electric field due to dipole on axial line. Electric field due to dipole on what? Axial line. Similarly, this will gives what? This will gives what? Magnetic field due to dipole. Magnetic field due to dipole on axial line. Okay, so please remember this. Okay, this is most important concept. Based on this, we have some problems in the next chapter also. Okay, if you're done with this, you may leave the class.
Thank you, sir.
Thank you, sir.